Okay, hi. Tonight we're starting characteristics of linear functions, what you've all been waiting for. Slope, x-intercept, y-intercept. This is some of the vocabulary for linear functions. So let's just jump right in and look at the different forms of a linear equation. Okay, first we have standard form of an equation. Standard form of an equation is ax plus by equals c, and write that on your notes. And then make yourself a note, take good notes, that the c is a constant. That means a number by itself. So I'll put the number in parentheses. It's just a number. And a and b are called coefficients. So if we talk about coefficients, we're talking about a number with a letter x or a letter y or whatever your variable might be. So these are coefficients. These are also numbers. Okay, point slope form is y, and this is a variable y, minus, we say y subscript 1. And y subscript 1 is a number. It's your y coordinate of your point. And usually we don't put that in parentheses. I'm putting it in parentheses to exaggerate that that's a number that we're going to put in there, where y is just the letter y. Equals the slope m, and then x is a variable minus x1. Now x1 again is the x coordinate of a point. That's why it's called point slope, because you use it if you're given a point and the slope. So this little x1, you might want to just put it in parentheses too to remind yourself, oh, I put a number in there. Okay, slope-intercept form is the most common. It's y equals mx plus b. And just like here, m, since we didn't have room up here, let's write it right here. M is your slope. And b is, guess what? Your y-intercept. That's why it's called slope-intercept form. And it's your y-intercept, not your x-intercept. And if you're taking good notes, maybe you want to add a little color. Slope is important. Y-intercept is important. Coefficients, all your vocabulary. Slope is important. I think I said that already. Okay. So we're going to look down here and we're going to look at slope-intercept form. So let's write y equals mx plus b to remind ourselves that this is slope-intercept form. Y equals mx plus b. So what happens if our slope changes? Well, let's say, what if our slope was 1? And let's just disregard the b for now and pretend like it's not there. So let's say we have y equals 1x. Or this would just be y equals x. Well, guess what? That's your parent function. Okay, so over here, write yourself a note. This is the parent function, y equals x, the parent linear function. Okay, and then what if your slope is greater than 0 but not 1? So let's say what if your slope is like 2? Well, you can, if you have a calculator home, you can try this. Otherwise, I can tell you that your slope, if it's positive, if your slope is positive, like 2 or 3 or 4, we call this a positive slope. So you just write positive slope. It's going to run uphill and it's going to be steeper like if m is a whole number, like 2, it's going to make it steeper. But if m equals like 1/2 fraction, it's going to make it flatter or less steep. And so I'm going to fix this for you in case you're behind a little bit. These are equal signs. Okay, and then what if our slope is negative? Then you have a negative slope. And one thing I didn't say back here is for a positive slope, it goes uphill from left to right. And for a negative slope, it goes downhill left to right. So you might want to write yourself a little note off to the side in the margin. Uphill, left to right. And this one is downhill, left to right. And I'm not going to write left to right again because we wrote it up there. So uphill and downhill. Okay, and that's all we're going to really, there's more to slope than that, but we'll leave that for when we get into transformations of functions. So those are the main things. What about when b changes? Okay, so if b equals 0, it's kind of what was happening over here. We just disregarded the b. You have y equals mx plus 0. Well, mx plus 0 is just y equals mx. You don't, and what's really happening here is your y-intercept is the origin. Because if we look at a graph, and we say, okay, where does it cross the y-axis? It crosses at 0. Well, if you're at 0, you're really at the origin. That's an x right there. Okay, because again, our y-intercept is where we cross the y-axis. If it's at 0, you're at the origin. Okay, the other thing is, what if b is greater than 0? So it's 1, 2, 3, 4, 5. Well, what happens is we have y equals x as our parent function that's right up here. What's going to happen is it's going to shift up if our b is positive. And if our b is negative, it's going to shift down. So it would move like down here. And if b was positive, it would shift up, like up here. Okay, and our b again is our y-intercept. It's where it crosses the y-axis. Okay, how can we define slope? There's lots of different ways to define slope. Hopefully you're thinking, well, it's the, well, hold on, let me get the right pen here. Hopefully you're saying it's the steepness of the line. Like if you're going skiing, you want either a steep slope or a less slope. It's the steepness of the line. Maybe you're saying it's the rise over the run. Maybe you think of that. Well, if we think of the rise over the run, really what we're saying is it's the change in y, that's your up or down, over the change in x. And really what we're saying there is we're saying this is called like rate of change. And oftentimes when we're talking about functions, we talk about distance and time. So an example of rate of change would be like distance, miles, over time, hours, miles per hour. That's one kind of rate of change. Another one might be dollars per pound. When you go to the store, dollars per pound. These are all types of rate of change. And if you're talking about real life, it'd be your miles would be your dependent variable, your hours would be your independent variable. Okay, and that's really, maybe you're thinking of some other things about slope, but those are the main things. Okay, so on to, let's talk about slope a little bit more. And we're going to talk about different ways of calculating slope. So what if you have a graph? Well, if you have a graph, you can just do rise over run. And you start at one point. So let's say we start at this bottom point. You could start at the top, it's up to you. Start at the bottom point. And we're going to go over, or actually, we're going to go up, sorry, rise first. 1, 2, 3, 4. So our rise is up 4, so it's a positive because we're going up 4. And our run is also in the positive direction, 1, 2, so it's to the right 2. Now what if we would have started at this point and wanted to go to that point? Well, let's do it that way. Let's go down 1, 2, 3, 4, so it'd be negative 4. And it would be left 2, so it'd be negative 2. Either way, it equals positive 2. Those are equal signs. I just always seem to not pick up my pen up. Okay, what if we have a table? Okay, if we have a table, we can do the change in y over the change in x, or it's more commonly known as y2 minus y1 over x2 minus x1. So y2, 19, minus 5. You could go the other way, go 5 minus 19. It doesn't matter as long as you're consistent. So 19 minus 5 over x2 minus x1, 4 minus 2. So we get 14 over 2. Our slope is 7 for this table. 2 points, it's the same way. y2 minus y1 over x2 minus x1. And I'll let you do that one. When you do it, your answer should be negative 8 over positive 5, I believe. Yeah, negative 8/5. And then this one's a little bit trickier. Well, when you get down here it is. Right here it's just y equals m x plus b. So our m for a is negative 2. For b, it's the thing with the x. M equals 2/3. So actually those two are easy. No trick to those. See if you can figure out what you have to do on the last one. Wrong color. Well, notice the y is by itself up here, but here the y is not by itself. So you can get the y by itself by subtracting. You want to take this whole thing away. We're not trying to solve for x here. We're trying to solve for y. So we got to minus whatever's with the y because it's being added. If it's being added, you subtract it. So y equals 8 minus 3x. What's with the x? Negative 3. So not too bad. You just have to know how to get the y by itself. Alright, moving on. Intercepts. The y-intercept, again, is where it crosses the y-axis. That's your vertical axis. On a table, look for the point 0 for x, and then a number. And the number will be your y-intercept. From an equation, your y-intercept is your b. From any equation, you can plug in, let's see, oh yeah, plug in your 0. I was thinking we were trying to find slope here, but we're trying to find y-intercept. So plug in 0 for x and solve for your y. Because if you're on the y-axis, no matter where you are on that y-axis, your x-coordinate, like if you're right here, your x-coordinate is 0, like 0, let's say 4. If you were down here, you might be at 0, -4, but notice your x-coordinate is always 0. So you can just plug 0 in for x and then solve for y. So what about the x-intercept? To find the x-intercept, you determine, from a graph, you determine where the line would cross the x-axis. On a table, now your y is 0, so you would plug 0 in for y and solve for x. Because again, look at your x-axis. On the x-axis, your 0, or your y-coordinate, is always 0. Okay, now this one, equations. Which equation are we going to use? If we have the slope and the y-intercept, hopefully you're saying, okay, the equation we're going to use is the slope-intercept form. If you have the slope and a point, slope. This is from the first page of notes, where this is a number, point, slope. If you have the coordinates for 2 points, you can find the slope by taking y2 minus y1 over x2 minus x1. That's your slope formula. And then you'll use one of the points and plug it into point slope. And again, this is a number, and this is a number. And the y and the x just stay a letter, y and x. Okay, what if we have a table of data? Well, you could see if there's a consistent rate of change or a consistent slope, and then you could use these formulas again. Or it's very common to just find a linear regression. And to do that, you'd have to use your lists and spreadsheets on your calculators. You can just put in parentheses calculator. So those are all your different forms of the equation, what you would do. Okay, let's do one more thing and then we have some guided practice. Okay, special lines and slopes. Okay, your slope for a horizontal line, it's a flat line, so just think, okay, can we ski on this? We could cross-country ski, so it still has a slope, it just has a slope of 0. And an equation might be y equals 5. Just any number right there. So y equals a number. And a vertical line, well, guess what? If you try it, can you ski? What's your slope on a vertical line? Can you ski on that? No, you'd die. So it's undefined. No solution. Okay, undefined. Some people might say no slope. And this form is x equals a number. Like x equals 8, let's say. Okay, parallel lines, your slopes are equal to each other. So we might say the slope of one line is equal to the slope of one line is equal to the slope of a second line. So M1, this is a 1, equals M2. And then examples would be like y equals 4x minus 8, and then y equals 4x plus 6. I have a little bit of trouble making my equal signs. Don't seem to be able to get that right. There you go. Perpendicular lines are opposite reciprocals, or negative reciprocal. So in other words, if my slope is 2/3, the slope of the perpendicular, I write like this, flip it over, and make it negative. And again, that's an equal sign. That looks funny, as usual. So examples might be, okay, if y equals, let's do 3/4 x plus 1, perpendicular line would be y equals, flip that over, and make it negative, 4/3 x plus 5. And those are perpendicular because their slopes are opposite reciprocals. Okay, let's practice. So let's find some points on this line. And put them in the table. And actually, yeah, let's go ahead and do this one. So 0, 1, 2, 3, 4, 5. Negative 1, negative 3, 3, 1, and 5, 5. So determine the slope. Let's just count. We're going to go up to 1, 2, 3, 4, up 4. And we're going to go right 2. So positive 4, positive 2. So our slope is 2. Find the equation for the line. Well, let's see. Go look here. We have, when x is 0, we have our y-intercept. And you can see from the graph too, it crosses our y-axis at negative 5. That's our, so this is easy. Y equals 2x minus 5 because we have our slope, we have our y-intercept, y equals mx plus b. And what are the intercepts? The intercepts are, well, we have the y-intercept is 0, negative 5. What's our x-intercept? Uh-oh, that one's not so easy to see. So what can we do here? Well, if we go back up above, actually it's probably on the previous page. Yeah, it's on the previous page. Let's go back there and look. It says to find our x-intercept, it says plug in 0 for y and solve for x. Okay, so here's our y, so let's plug in 0 for y and solve for x. Okay, so now we add 5 to both sides. And we get 5 equals 2x. Divide both sides by 2. And now this is the case, typically I tell you to leave it as 5/2, but since we're dealing with a graph here, let's go ahead and change it to a decimal. I don't like you to do that very often, but this is one of those cases. 5 divided by 2 is 2.5, or 2.5. Sure enough, look, we're at about 2.5. So our x-intercept is 2.5, 0. Which is right, again, right here. X-intercept, where it crosses the x-axis. And our y-coordinate right there is 0. That's why we put 0 in for y. Okay, I'm going to stop there. And I hope this is helpful.